Welcome to this installment of Epidemiology of Everyday Life Lessons. This installment continues on from our last installment about modeling relationships, but in this installment I'm going to show what that relationship looks like graphically. So everything I'm about to show you is the same as what I just discussed, but I'm just going to discuss it now in graphical terms. I've put the model that we're using in the upper right hand of the screen, and we write out the two possible values of our x variable, 0 for females and 1 for males. If x equals 0, then we write 0 in place of x. Because anything times 0 equals 0, we can cancel out the whole second term. We end up with the mean height of females as our best guess when x equals 0. Now we can look at what happens when x equals 1, which occurs for males. We start with the exact same model, but now we enter a 1 in the place of the x.
We begin with the first term, y bar for females, and then
the second term does not cancel out, so we need to see what value we get. Next, the equation tells us to move enough values to the right to equal the difference between the mean male and female heights. The pink bracket here represents that value. As a result, we end up at the value y bar for males. To see what the equation would look like in numbers, we can see that the approximate values look like in the data. I rounded the values here to make whole numbers, so it'll be a little bit easier to see. In the end, this single equation gives us our best guess for females and males. We don't need two separate equations. Now we need to factor in our error, which remember is always there. Our best guess will still be wrong by some amount, so we record that with the same notation that we used before, EI. We are also going to use a different symbols to represent the values, the Greek letter beta. This notation seems unnecessary now, but will become a little bit more useful when our model gets more complicated in future episodes. So let's take a little quiz. What is your best guess of someone's height if you don't know their sex? It's the overall mean of the data. You don't have any additional information to use, so you would end up at the average, just like we talked about in previous episodes. Now, what is the best guess of someone's height if you know the person is female? Using the terminology of our model, the value will be beta 0, which equals the mean value of females in the data. Now, what is the best guess of someone's height if you know the person is male? It will be beta naught plus beta 1, which equals the mean value of males in our data. Another way of saying that is that the value equals the female mean plus the difference between the male and female means. So we've figured out how to estimate the best value using a single dichotomous variable. In a future episode, we will discuss the uncertainty of this model, because remember, you should always report the model and its uncertainty. To review, knowing more about an observation in our dataset provides us a better guess if we include that information in our model. Second, we now call our best guess y hat, or y hat if you prefer. With a dichotomous variable, beta naught equals the mean of the first group, and beta 1 equals the difference in means between the two groups. That's all for this edition of the Epidemiology of Everyday Life Lessons. I look forward to seeing you on a future installment.